Question 20 offers us quite a nasty question about gradients and lines and everything. We've basically got 2 points, A and B. There is a line M which goes through the midpoint. So it will be very helpful to find the equation of this line M. That will get us the coordinates of point C, which is the top of the triangle ABC, whose area we need to calculate. So let's start with line M. But before we do that, we need to find the midpoint of AB. Now, what does x do? X climbs from -6 up to +5, which is a journey of 11. So halfway is 5.5. Add that on to 6, so the x-coordinate, -6 plus that, -0.5. Similarly, the y journey goes from 2 up to, that's a journey of 3. 1, so the y-coordinate is 2 plus a half, which is 5/2. So the gradient of AB is equal to the rise over the run, the rise being 1 over, it's a positive gradient, 1 over 11. So line M, y equals M of line M, well, that's perpendicular to AB, so it will be the negative reciprocal of 1 over 11. So our gradient here will be -11x plus c. But line M goes through the coordinate here, the x-coordinate -1/2, 5/2. So if we put these values into our equation, we will get c. So we get 5/2 is equal to -11 multiplied by -1/2 plus c. Multiplying through by 2 and tidying up, we get 5 is equal to +11 plus 2c. So therefore, 2c is equal to 5 minus 11, and therefore c is equal to -3. Does that look about right? Well, yeah, it does. So the coordinates of big C, we need to sub x is equal to -1 into line M with all its various bits. So we get y is equal to, x is -1, so this turns into +11 minus 3, which is equal to 8. Numbers slightly getting better now. So this point C is sitting at -1, 8. So we've got a triangle now, ABC, that we know all the coordinates of. So all we need to know is find the length of AB and find the length of the perpendicular from the midpoint up to C. So if you imagine a triangle underneath, a right-angled triangle doing that, we know this distance and we know this distance, therefore we can find AB. AB is given is equal to the length along here, which again is our old rise of 11 squared, plus 1 squared. Therefore, AB is equal to the square root of 122. So if I now call that the point M, we know its coordinates. Its coordinates are -1/2, 5/2. So this tiny little thin triangle here, this is the hypotenuse, the base is 1/2, and the height is 8 minus 5/2. This diagram is really cluttered and quite difficult to see, so I apologize. But CM squared, which is the diagonal, this green diagonal here, is equal to the base distance. The base distance is climbing from -1 to -1/2, so this is 1/2 squared, plus the height difference, which is from 5/2 to 8, which is 11/2 squared. And therefore, cm is equal to, if you work that out, you get the square root of 122 over 2. So these are the two bits of the triangle we now need. So with further apologies for the space, come up here, area ABC is equal to half the base times the height, which is the root of 122 over 2, multiplied by the height, which is the square root of 122 over 2, which turns into 122 over 4, which is equal to 30.5. And that's the end of a rather complicated question, made worse by the fact that all our work is done in a very, very small space. But there you have it.